Julian, we are on live. You can start
Yeah,
recording.
sure.
We're
Sure.
live, right? Mm.
Hi, everyone. A very warm welcome to this webinar of Let Us Talk It. We are here to serve the community. We are here to serve anybody that feels uh, uh, a need to learn something new. Uh, Anybody who thinks that will be inspired by a community which is out there, bringing in different topics every week, 4 days a week. Um, and we have these through webinars, of course. And we welcome all those who have joined in on YouTube, LinkedIn, and Facebook. And if you think the topic is something that might help somebody, we highly recommend that you share the link with them as well. And we do these webinars every Tuesday, Wednesday, Thursday from 12 to 1 p.m. EST. And we do our Let Us Talk It Youth series every Saturday from 4 to 5 p.m. EST. And if you want to attend or be a speaker, or you know somebody who could be a speaker, please let us know at email us at webinar@letustalkit.com and we'll promptly reply back. And for this session, if you have any question, please do put it in the chat box if you're joining in Zoom, or if you are on YouTube, then please put it in the comments section and we'll take it at the end of the session. There will be a 10 minutes question answer session and we can address them. So, coming to today's topic, it is highly technical. It's a buzzword right now: data science in business applications. And in this webinar, you will get to know some use cases of how Fortune 500 companies use data science to earn money. Also, some practical usage of data science in the past will be also shared. So, coming to our guest speaker, from the day I connected with him, just loved his very fun and his nature and the way he talks and communicates. Absolutely, it was very warm and loving, I would say. Being a professional, and knowing us so less, but still doing it so well, we really appreciate. Thank you. Our speaker today is Jared Teo, and he has 15 years of experience in building machine learning models for companies including IBM, SPSS, Nielsen, Rakuten, and Samsung. He is a respected data science speaker and was invited to give a talk at A-Star, a well-respected Singapore government research agency, and Taobao on how data science can be applied in business. He is also an enthusiastic supporter of developing the younger generation of data scientists. He is currently the chief data scientist of Direct Sourcing Solutions. And when we say that we want to bring this world together, we are extremely glad that we have a guest speaker straight from Singapore. A very warm welcome to Jared. Over to you.
Hello, hi everyone. I'm Jared, and thank you so much for the introduction. So today's topic is about how do we actually apply data science in business practical solution. So maybe I can actually just share data first, right? Now, yes, I know that. Can you see my screen? Yeah. Just
No.
no?
Yeah,
Okay.
yeah. Can you
Let me
share?
make sure. Share screen, right? Let me
Yeah.
just do a share screen. Just hold on a while. Share screen. Cool. Okay. Now I believe you can see my screen.
Yes. If you
Okay.
can have
Cool.
it in the present mode.
Yeah. Just before I start the entire thing, I'm just going to actually just share with someone out there who is actually a data enthusiast about this story behind this data. This is actually a data which was actually a question on one of the statistical forum. And this statistical forum has around like 3,000 statisticians worldwide. And you can actually name them in be it Bain or be it actually in Nielsen or be it in IBM. They are actually the top people there sitting down there and then just chatting with each other about technical stuff. Now, so this question actually allow me to meet my mentor. Okay, so my mentor is someone who is actually in IBM doing. He's actually a principal software engineer there. I don't want to name him. He's going to hammer me if I bring him public. He's in retiring already, so that's why I don't want to actually name him. So basically, what happened here is that you can see that these are all IDs, right? So the question that was actually asked during that forum, before Kaggle happened, this is actually what we do for fun, all right? So you can see that all these are 1 and 0. 1 just means that the person default on the loan. 0 means the person did not default on the loan. The question by the person was that, so I want to actually find the first time the person actually default on the loan. So this is actually ID1, he default on January, correct? This is ID2, he default in December. So he wants to actually find for all the record with one additional column here, when is the first time the person default on the loan? Okay, so the person who got it right was my mentor and me, and that's actually where we know each other, and he just shared with me some of his fun stuff for over 15 years. All right, now I'm just going to actually keep this data here. I'm going to review the answer at the end of this talk. Just actually for the fun of everyone, just trying to think of, so how do you actually find the first time the person actually default on the loan? That's all, okay? So just think about it, okay? So I'm just actually going into my slide. So my slide is this. Warm welcome, and then we're going to actually talk about data science in business application. Okay, so just actually a bit about us. We are actually using Alteryx. We are actually an outsourcing company, and basically these are actually our people. Yeah, and then Brian is actually our CEO. And then we have our COO, we have our Chief Human Resource Officer, and these are actually our people. And that's me over there, right? So our office is actually in this part of the world, basically, all right? And basically we talk about passion, innovation, unity, and flexibility. And we have our delivery center in Clark. It's a very nice place. And that's actually our office building in Clark. And then that's actually how our office look like. That's Manila. And that's me. As actually mentioned, I have 14 years to 15 years experience in machine learning. We were all actually called statisticians last time, all computer scientists last time. And then we had the SPSS versus SAS war for no reason. Now it's actually Python versus R, all right? For some reason, maybe, all right? So basically I use SPSS statistics mainly. I use Alteryx, use a bit of Python. I used to actually use R as well. But the main thing in data science is actually to solve business problem, okay? So these are actually some of the projects that I was involved in the past. Yes, you see, right, Singapore Navy. In fact, I was actually involved in some of the armed forces analysis to actually find out what actually makes a soldier break. Yeah, so we profile soldiers. So we have things like in Nielsen, we have projects that is involving, it's a very interesting project, which is to actually find out what the person served, and based on what he served, and based on what app he used, we actually go and find out, so what TV channels to sell to them. So this is actually for a telco company. And then we have People's Association. That was actually a memorable one as well. I was supposed to present to Lee Hsien Loong. so in the end, the directors do it to present to him directly. So I didn't have the chance to that. So I was working in Samsung, and then I was working in. I was actually working for HTV and things like that. So I'm going to actually share a bit about some of the experience that I had in helping this company, and then you actually see. I'm not going to actually discuss it. Hopefully, not too technical, but more towards say this is the business problem, and then how do we actually use data to actually solve the business problem. Now, in data science, it is always like that. We start with a business problem. We look at what data we have. We look at what software, what statistical methodologies that we're going to actually use, which is what software resource that we have. Are we using Python? Are we using SAS, SPSS, or what? And then we plan accordingly. Everything starts with a business objective, and then we move towards that action on solving it. Okay, all right. Now, I'm going to actually share this interesting video. I don't think you can hear the video, but don't worry, I'll just actually narrate to you what's actually going on the video. Why do I actually share this video with you? It's because to some of the young data scientists out there, they actually have a misconception that data science only start recently. No, it doesn't. All right. So some of our seniors are actually doing data science in the past. And this is actually a very interesting one that actually translate Russian to English. Now, for data science, it is always like that. We think that we code and then and then we get a certain accuracy and then it's done. No, in data science, when you actually want to develop a model, try to actually have an end in mind. And then this end in mind actually tries to do one thing. They are trying to actually find out and spy on what the Russian is actually doing during the Cold War. So that's why this group of data scientists are actually using a method to actually find out, say, how do we actually translate Russian language into English? All right. And it's a $500,000 super calculator to actually translate Russian into English. Okay. And you can see that this is actually their old server. Yeah. It's a core obsession of keeping tab of what Russian is doing. Yeah. And then they're thinking about replacing human translator as well. This is actually an experiment, but they are actually doing it in terms of analyzing words in a 1 hour time frame. Okay. So this is actually a very interesting interesting kind of thinking for us. That is, data science is actually not, say, just recently. It's actually something that has already happened in the past since 1960s. Yeah, since 1960s, they are already doing this. In fact, in this video itself, you can even see them designing a checkerboard whereby they play chess with a computer itself. I'm just actually going to show as well that you can see that they are actually doing a checker with a computer. Yeah. But of course, for this one itself, it is not going to actually earn money for the company. What is going to be earning money for the company is actually the one that is translating Russian to English. So as a data scientist, you could actually be serving a company or you can actually be designing a product. So always have an end in mind that does your product or does what you does it actually eventually serve and solve a very important problem? If you're going to actually design a checker, maybe it's actually for fun's sake or maybe for competition's sake with the best checkers in the world. But from what I see is a personal gut feel is that Russian to English, keeping tab on the Russians, this is actually a very powerful solution, which is actually well sought after by maybe say the US government back then, and they're going to pay you money for it. Okay, so that's why I always tell young data scientists, when you actually want to design a data science solution, have an end in mind that is able to actually serve something. And this is actually what we're going to actually look at next, which I'm going to actually say minority report. Yeah, minority report. It sounds funny. Now, why is actually called minority report? Let me just actually go to this video. Okay, so minority report, again, some data scientists were telling me and say that, look, Data science is just start recently. So you can see that this video is uploaded in 2011. You see that? Okay. So what is actually this about? I'm just going to narrate a bit what's actually it about. I'm going to mute this. So you can see that for this one itself, what it's trying to do is it's trying to actually predict crime before it happened. And then this is, they're saying that you can actually predict weather, okay? You can predict customer behavior, okay? Can you actually predict crime before it happened? It sounds really very psychic because it really sounds like Minority Report. If you actually have watched this film, they actually pre-know when the crime is going to strike before it happened. So out of some fun sake on this project, the reporter decided to actually call it the Minority Report project. The police is able to predict when the crime is going to happen. You can see that it dissect the crime into parts, dissect the country into parts, and then pinpoint a rough estimate of when the crime is going to happen, where it's going to happen, and on what crime is going to happen as well. The reason for so is that because they say that criminal is actually a human, and that they are able to profile what the criminal actually think. And a criminal actually will try to strike the same area if they can get off with it. All right. So that's actually the assumption, but they are able to actually use data to actually prove this assumption and solve a business problem. The business problem is to reduce crime. And you can see that they actually have fit this gadget on the car. Remember, this is 2011. They fit a gadget on a car, and then where the police is able to actually use this gadget to catch criminal, to identify them, and then to actually know where they are roughly going to strike. Not say identify them, but they're able to identify where they're roughly going to strike. And they have reduced the crime rate as well along the way. That's actually the Minority Report. And some of the young data scientists were quite surprised and say that, are you sure this kind of thing was done in the past? I say, yeah, it is. It's really done in the past. All right. Now, let me just actually go back to our slide, okay? Which is this one, all right? So then you have actually seen what we have done as those senior data scientists have done in the past. I'm just actually going to go into what I have done currently, okay? So in my company itself, I designed this product, which is actually called DSS Customer Observer. What DSS Customer Observer do is that first is actually segment the customer into premium, at risk, or actually non-active customer. So once you actually know that it's premium, at risk, or non-active customer, you can see it's non-active. The next thing that we do is that we pinpoint so which customer actually have a chance to increase in spending. All right. So once we actually know that, oh, okay, so this is at risk, you want to actually save an at-risk customer who is at risk of leaving the company versus someone who is actually still a premium customer. A premium customer is going to buy anyway, all right? And then this is actually where the decision is actually made. That is, if there's actually a discount, they might actually want to give some discount to the at-risk customer to save them, okay? So instead of everyone having 20%, this premium customer might only have 10% discount. At-risk customer will have 20%. The non-active, we might actually give them 30% discount. Okay, this is actually what we do in Rakuten actually. All right, and then we actually decide as well, say, okay, so you're an at-risk customer. Do we show you our hero product? In Rakuten itself, we are very fond of hero products. Those products actually doing well in the past. We actually show them to the at-risk customer first, and then we show them to the premium customer. Is this bias? Yes, this is actually kind of prejudice. But then, well, we're trying to actually save customer, right? Our rice bowl is actually at stake. All right. So imagine that you might actually not see yourself getting a PS5 versus your friend having a PS5. The reason for so is could be that because your friend has already been a premium customer, keep buying every month and all those things. but you are actually not buying every month, and then you suddenly have a PS5 shown to you, something like that. All right, I'm just making it up because uh, the more interesting thing is that we are actually trying to give allocate discount, but it could happen that we will allocate our hero products to actually what kind of status you are. Okay, yes, it's a bit of prejudice marketing, but that's actually what data science is trying to do, is trying to actually allocate you into basket so that we can actually develop marketing strategies for you accordingly. And then we customize what kind of product that we're going to actually show you as well. So for an at-risk customer, we know that the last purchase product is Ben and Jerry. The next product to purchase that we were actually going to share with him, it could be a Popsicle, could be Magnum, and then it could be actually this brand. All right, this is actually not an ice cream. Why? Because we are trying to allow you to buy something that you're familiar with while pushing you into new genre of product. That's actually the whole idea of e-commerce, because we cannot allow you to keep swimming in the area that you are familiar with. You'll get bored. So we try to introduce you something that is related to Ben and Jerry, because we know that 90% of the customer buy Ben and Jerry actually goes on to buy this product. And then you buy Ben and Jerry, you haven't buy this product. Definitely will show you this product, right? So imagine this, be it actually your YouTube, or be it actually your Spotify and other some music listening platform. Why do they actually have things like recommended videos or recommended music for you? Sometimes it is not by chance. It's because we know that you have mentioned Jerry, you haven't actually get this. We are trying to actually push you into new genre so they stay longer with us. All right. So that's actually how DSS customer observer work, and that's actually what we do for our client over here at DSS. And then that's actually what data science can be used in terms of the in making money for the company itself. All right. Now I'm actually going to talk more into a technical part on so we know all this about segment profiling and next product of purchase. Now, so how do we actually, what's actually the mechanism behind it, right? So let's look at this. We are trying to find potential customer. We are trying to actually profile you. So how do we know that profile A is a female married less likely to buy a Samsung A series phone, while profile B is a female single earning less than or equal to 5K and likely to purchase a Samsung A series phone? How do we know that? Okay, it's all because of this whole chunk of information here. Now, I'm just going to actually make sure that you can see what's going on. So I'm going to actually slightly zoom in here. So everyone actually start at this point, which is A series customer. Okay, so no and yes. No is 56%, and then yes is 44%. Now, Samsung cannot sue me because this data is actually a loop out data. I looped this out myself. Okay, so it's very easy to loop out a 3 million record data to actually do presentation. I have actually looped out a 1 billion record data on my laptop. It didn't explode. My laptop still worked fine. so yes, you can do that. So I looked this out practically to actually share with C-level people on what is actually profiling about. So we know that this is an A series customer. Now, for data science itself, is statistics important? Yes, you can see that this is based on p-value and this is based on chi-square. If I didn't remember wrongly, this is actually a trait, okay? A trait decision tree. So we know that decision tree actually says that gender is the first decision to split into male and female customer. Now, this is actually 1397495, right? If you add this up with this 1711965, you will get back this 3109460. Definitely. Okay. So then this is gender. The first split is female. So how do we actually know profile A? What is our profile A? Profile A is female, married, less likely to purchase Samsung A series phone. How do we know this? We know this because it's a female, okay, that say no first. The first split says that is increased in no. You can see that this is 56%, right? But because it's a female, the chance actually increased to 71.6%. Okay. Then, if we actually look at marital status, this is marital status. There's a next split, there's a married. So it's a married. The chance of saying a no decreased to 55%. So what is how do we use the decision tree? Is that we look at the end path. So this is the end path. The end path says that female married, the chance of buying an A series phone is a no at 55%. That's how we read a decision tree. No magic. It's like that. Okay. So then if it's a single, the chance of her buying an A series phone is a 92%. It jumped from 72% to 92%. Okay. Now, then the next split is income. So income, if it is more than 5K, it's a no completely. If it is less than or equal to 5K, it's a yes at 81%. Interesting? Okay. Now, did I actually decide this split? Someone actually asked me, so Jared, you decide this split? No. The data actually decide this split itself. Okay. So we will actually put in the factors that we believe that will impact the business. And then we plug in the decision tree and we test. So which one will actually impact the decision of an A series phone purchase? Now, this is actually the interesting part. We know by data that actually female married is a no. Okay. Female single earning less than or equal to 5K is a yes. Now, data scientists do not work alone. We actually work together with business. So we will actually go off to the business and then we discuss with them, say that does this result actually sounds logical to you? So female married is actually a no, and then female single and earning less than 5K is a yes. Now, if you actually plug in one more information, which is not here, is A and J series phone are actually budget phone. Okay. N and S, which is the Note and S series phone, are actually luxurious phone. Okay. So you don't see a job title here, right? You don't see job title. That's actually not a problem. Okay. That's actually a limitation of resource, which sometimes we can't calculate everything in the world. So from here, we actually can somewhat guess if this is a female married, the reason why she said no, it could be that this lady is actually going for an NNS series because maybe say she's actually in a well-to-do job, she's married, so that's why she said no. She don't buy A series phone, but she go to your NNS series. She don't buy budget, she go for luxurious because she can afford it. Okay, but if it's actually a female single earning less than or equal to 5K, the reason why she's buying it is because she can't afford the luxurious phone. So that's why she's buying the budget phone, the A series. So 81%. You can see that if it's more than 5K, it's a no. Okay, make sense? All right. So once the business is actually seeing this kind of trend that they believe that is actually currently in their business, now then decision tree can actually come in and actually talk about trends that the business maybe doesn't actually see so far. So if it's a male, it's a yes, but the interaction channel is actually push, social or email. Push means that you actually see app and then push to you. You have the Samsung ad, it push to you. This is through social media and this is through email. All right. So if it's actually through email pushing, is a yes. If it is through social media, is a no. If it's through push, is a yes. Then you will actually decide, say, next split is marital status after this. So if it is a male that is through push and he's actually a married male, is a no. But if it's actually a single male, it's a yes. This could be actually be an established guy, and he's actually going for an N and S series. So this is actually how the decision tree works, basically. Cool. All right. Now, then we look at decision tree. The next thing we're going to actually look at is actually on this one. Let me just actually make my slide bigger. Okay. All right. Is next product to purchase example. So then you have actually seen next product purchase in your life before. Some people told me, they said, Jared, data science is out for me. It's too too complex. I definitely have not used it. I would just actually ask them, have you actually shopped on Amazon or have you actually used YouTube? All right. You can see that Amazon actually specifically tell you, Amazon has new recommendation for you based on the items you purchase or towards you want. This is a real Amazon webpage. Okay. So this is the really next product to purchase. They are already pushing new products based on what you purchase or you told them. Okay. So this next product to purchase, and then that's actually how Amazon actually use it in their website itself. Now, you have actually seen so far on how we segment customer, how we profile customer, and how we see the next product to purchase. You have actually seen how actually profiler works. This is something that maybe say most data scientists will not actually show in public. They will not actually show the result. All right. This is what get me fed. Because you see, yes, it is good to actually build a model with 80% accuracy, but then the interesting thing part comes in validating a model. To actually say that, yes, you say that it's 80%, does it work live? Okay, this is actually what we do, which is live testing. So this is actually buyer profile result. Now, this is a very difficult model. So you ask any data scientist, 1% buyer and 99% non-buyer is a crazy profiling model to build. I was asked to actually build this in Samsung. Why I said it's a crazy model to build. Machine learning models are not smart. Sad to say that, because you see, 1% TV buyer and 99% non-TV buyer. The more data you have on non-TV buyer, your machine learning model is going to actually predict non-TV. It's because there's more information on non-TV buyer. There's not much information on TV buyer. All right. So you can see that this is actually the first part of why this model is actually a difficult model. The second part about this model that's being difficult is that the company only gave me ID, age, gender, product type, product registration date. That's all. Okay. And the requirement for this model is number one, does the person need? Number two, can the person afford? And this is for QLED TV. And you can see there's if it is ID, age, gender, product type, product registration date, there's no information to actually just to telltale whether the person need or whether the person can afford. Nothing. All right, not even income, not even price tag. I was asking them, so where's your price information? They say, well, it's all actually locked up in the merchant site. The merchant, Harvey Norman, and all those, they won't share with us. It's because it's the data. So what can I do? All right. Well, that's why it turned me fat. So what I did was that the first thing I do was I use assumption. Okay. So we know that that's the business objective. Business objective is to predict sales of QLED TV. We have data, not much. Software, yes, SPSS and all those things. I use them. And then it doesn't matter because the most important thing is that, so what kind of information do we want to pop in? All right. So we don't have much information. The first thing I did was I actually go and calculate the number of N series, S series, A series, and J series phone that a person purchased. We have product type, right? So that's what we do. That's what I do. So N and S, my assumption is that the more N and S that you buy, the chance that you will actually be able to afford QLED TV. The more A and J that you buy, the phone, the chance is maybe you won't actually have the budget to actually buy the QLED TV. So because you see, the more N and S that you buy, you're buying without contract as well. So maybe you have some spare cash, and hence the likely profile is that you are likely to be able to actually purchase the QLED TV if you buy more N and S phone. Okay, all right. So, all right, that may be answering the first question, which is whether the person can afford the TV. Now, the second question is, can the person actually, does the person need the TV? Now, this is actually something that I did, which is a bit way out of the way. I was calculating the age of washing machine, fridge, aircon, and then my cloud engineer was saying, Jared, are you mad? They say, well, yeah, I'm calculating that age of washing machine, fridge, aircon, all those things. And my idea is this, okay? When the person actually move in, they will actually buy washing machine, fridge, aircon together with the TV. Am I right? So if you actually think it this way, the younger the appliances, the chance of you buying the TV is higher. Sorry, it's not higher, it's lower. So the younger the appliances, the chance of you buying a TV is a no. And then the older the appliances, the chance of you buying a TV is might be a yes. Because then because you buy all this together when you actually move into the house, right? All right. And I deliberately didn't include a TV information inside because I don't want to include bias in the model. Okay. And I actually do statistical testing before I plug all these feature inside. So my assumption is that the younger the appliances, the chance of you buying a TV is actually a no. The older, the chance is a yes. And I prove it through statistical testing and say that, oh, yes, this is true. Why didn't I actually put it immediately in the model? Because it will run and it will take very long time to run. But at least I test it individually first and then decide should I actually put it inside. Then I can actually tell the senior management first and say that I'm going to actually use this feature. And then initial finding through exploratory data analysis, I know that this could be actually good features to actually put it inside. And when I actually put it inside, this is the result. Okay, so don't worry, I'm just going to explain a bit what's going on here. Normally, we actually put train and testing data. Train is 70% of the data, testing is 30% of the data. And then what we're trying to achieve is that we're trying to achieve an equal accuracy between these two. Okay, so what is actually training and testing? Training is a machine learning model is like a kid. All right, so you actually give him labels of what is actually an apple and orange. You give him labels. You don't show him what is apple and orange. When the testing comes, you show him the actual apple and orange. You ask him to differentiate what's an apple and orange based on the label. Or apple is red color, orange is orange color, and orange is rough skin, apple is smooth skin, and all these things. Then if your testing is able to show the same accuracy as your training, then this model is a keeper. Okay, so you don't usually see these two being the same. Okay, most of the time is this is higher than this. When this is higher than this, imagine this is 88% and the testing is 50%. It just means that your model is able to predict in fairy tale manner that 88% of the time correct. But when you actually go live, it's only 50-50. This model is not going to work. But I'm able to actually do it in some way, which people call it hyperparameter tuning, that this accuracy is the same, 88% and 88%. Remember, our model only have 1% TV buyer and 99% non-TV buyer. So to get this result, it is actually almost impossible. I'm not going to actually share with you how I actually do hyperparameter tuning and all those things. That one is actually my secret sauce, right? So then this is not just actually the end. We are actually kind of interested to actually see more. So this is the actual, this is the predicted. So actual is non-TV and TV, right? This is the predicted, non-TV and TV. We are trying to actually see how much accuracy it is that we are expecting here. So yes, this is 88%, but it doesn't actually mean that 88% is predicting correctly for non-TV and TV. Everything might be lopsided to TV, and hence you see 88%. What we're trying to actually see here is, oh, okay, the actual is non-TV, the predicted is 83% for non-TV. The TV actual versus the predicted TV is 89%. So we are actually able to actually predict well for non-TV. We are able to predict well for a TV buyer as well. So this is a good model. Okay, but then the Koreans actually aren't very happy about this yet. They say, Jared, we tested on 12 months. Yes, that's actually where I cringe and then start eating potato chips and all those things and get fat. But you see, 12 months, we're still able to actually get the same result, 88%, but it deteriorates because model expire with new data and new trend coming. You're going to actually see the accuracy drop. the accuracy actually dropped from 80 over percent to actually around like 69% ish. So the golden range for a machine learning model to be good in numerical data is around like 65% to 85%. Okay, beyond that, which is 86% and above, there is still okay to accept if it is 90%. I mean, at least for me. If you actually see a model that is 99.9%, if you see a data scientist be able to predict 99.9%, please recommend him to me because I want him to predict the next lottery. We are not God, we are human. So if anything that's above 50-50, it is okay. If it's a 65% to 18, you see above 50-50 to 60 is not okay, sorry. If it's a 65% to 85% range, that's actually slightly the golden range. I'll actually aim for 75% or 80% or best 85%. If it's 99.9%, something is wrong with my model. I will actually discard it and then try to see what's wrong and then do hyperparameter tuning and then do feature engineering and all those things all over again. Okay, so the golden range to me is that 65 to 85%. I built the model in the telco company before, the same thing that I actually built like that. That model works for 5 years. It is still working. There are 10 models working in the telco company. It is still scoring for 5 years so far. Still earning money for the company. But guess what? Data scientists are poor people. I'm still poor. Well, I'm earning, those models are earning money for millions for the company, but I'm still poor, right? So that's the life of a data scientist. I'm going to show you as well, that's for profiling, next product to purchase information, all right? So this is next product to purchase. This actually happens in a telco company. And then you can see that the company may send at 8.5 million. So the CEO say, we may send 8.5 million, we earn back 40K Thai baht. And that's actually our sales per email, which is this divided by this. Jared, you can actually do something for us, I'll treat you the beer. That's what he told me. Okay, so I actually take the data back on August. I send 88K, I earn back 74K. Okay, and you can see the reduction of email sent and the increase of the sales earn out. And that's actually 85 cents per email sent out. Okay, he was astonished. All right, so the astonishing part comes back to me is when it's a December Thai protest period. I'm always an unlucky data scientist. I don't know why. Thai protest period comes and then my model is actually doing well and suddenly Thai protest period. Who will actually do machine learning models during country unrest? Right? We don't even know whether our delivery van is going to reach them in terms of our e-commerce product. And we sent out 316K email and then hoping that by some miracle, it will earn back. And guess what? It earned 483K for us. And then it turns out that when it's a country unrest, people actually stays at home to shop. This is the same situation for now, which is COVID. All right. At the start from Jan to March, everyone is actually saying machine learning model is going to fail. But from what I actually see is that machine learning model might not actually fail for some channel. For example, maybe say an online purchasing channel. And then since I have the experience of doing this last time, I did the same thing for a company and they were shocked. They say that, how are you going to do that? To actually predict someone's sales during COVID, I said, that's actually what I did. Okay. And then guess what? During the first campaign, I can still remember, I sent out 9,000 email. I earned back around 80K Thai baht. Yeah. That's actually at the start where the protesters actually take over the airport. That was 9,000 emails and now earn back around like 90K Thai baht or 80K Thai baht. And then that's actually twice of what they do in a month. I did it in a week. Okay, so that's actually, you can see it's already 40K earning back. This is 483K. That's already that much in a month, and these are month by month comparison basis. Eventually, the sales earn back is $2 per email sent out compared to what they usually earn. And then I was actually asking them, I said, look, I have actually significantly reduced your email from 8 million to this much. I've increased the sales from 40K to this much. I have actually increased the effort from 5 cent, 0.005 cent to $2 per email sent out. I was asking the CEO, why did you only give me 20K customer? Can you give me 2 million customers? What will happen if you give me 2 million customers? I was asking the CEO, would you like to retire actually? So that's actually next productive purchase, and this is actually a result that I managed to achieve in the past. Although even during a country arrest, even during country unrest, I'm still able to actually provide sales through my machine learning model, and I'm still doing it now at the moment with my DSS customer observer. Okay, so then so far, I have actually introduced a few business applications in the actual world and how machine learning models, how big data, how data science can actually earn money for the company. Now, from what I actually see so far for data science, for data scientists, they can actually largely be broken down into a few roles: numeric scientists, text scientists, image scientists, vocal scientists, video scientists. Vocal scientists will be somewhat like imagine your Bixby or your Siri. So vocal will actually add on with your text scientist to actually quickly do a search so that your Siri can work, your Bixby can work. Okay, and image scientist is maybe say for airport when they actually try to catch criminals. Video scientist as well is working in China at the moment to actually catch criminals, working very well. But their CEO also say that the model actually is around like 85% accurate. They are not 99.9% accurate. They share on with Chua En Lai, a celebrity in one of our talk show on artificial intelligence. They actually interview that China company that's actually doing the video capture on machine learning to catch criminal with the government agency. So yeah, he said that it's 85% accuracy as well. So I'm actually I like numeric a lot, and then I'm actually looking at text as well. But most of my focus these days is actually on numeric, and that's actually what I can see is that data scientists is largely formed into these 5 areas in 10 to 20 years to come. In fact, you will see them specializing in some of this, or actually doing, two of this together or two of this together. And they might, the nice ones at the moment, they actually create products. One of the products that I've actually have seen so far is actually a glove that can actually speak for people who have inability to speak. So when they actually wave their glove, they are able to actually produce sound, whereby they translate the sign language into actual speech. And you can actually think that some of this actually is in work, which is text, video, and vocal, as it is actually in work together for the product to actually work well. And VC, venture capitalists, is actually investing in the product. All right. So when you are a data scientist, try not to actually just say, "Oh, I know deep learning, I know neural network, I know C5, and all those things." Try to actually have an end in mind. So what are you going to do with this model to actually earn money so that you actually can make your big data, your machine learning into something that is practical, something which maybe say even Bill Gates will be interested to actually be hearing more, something which you can actually talk about it in an elevator pitch. My elevator pitch to Bill Gates will be, I can actually find risk customer and then find which one have a higher chance to increase in spending, and then find what's actually the next three product to sell to them. That's DSS customer observer. So what's yours? It's up to you to think. And then hopefully you have an enjoyable time like me as a data scientist as well. All right. So that's it for my presentation. If there's actually any question, you can feel free to actually email me. Yeah. All right. So that's it. So shall we move on to the next segment? Yeah.
Sorry, what did you say?
Shall we move on to the next segment, which is Q&A, right?
Yeah, absolutely.
Mm.
If anybody has any question, they can unmute and ask the question. And Vamshi, if you have any question on YouTube or Facebook, please let us know.
No questions yet.
Yeah, I see this one. Yeah. Wonderful
Oh yeah,
presentation, Jared. Thank you so
I
much.
I remember. Okay, I remember something. This question, remember? I haven't actually stopped this. Sorry about this one. Slightly overrun on this one, right? So then, how do you actually do this one? Okay, you can. I can actually quickly solve this for you.
Your voice
So
is
if I
breaking.
actually run this one, and you can see that I'm able to actually pick up for each of the case here. This is actually January, which is here, and this is actually December, which is here. Okay, and then what this actually did is you actually think a lot about if statements. It will be wrong because what is actually needed is I'm going to actually share with you the actual output. I'm sorry if this is overrunning, right? Let me not delete the columns, and you can see that this is actually what I did in the background. Okay, so what I did was I actually convert everything into string. You see that? And then I actually concat everything together. And what I did next was that I actually say find the first occurrence of one within that string itself, and we know that this is one, and then I actually just actually label it as January. We know that this is actually happening one. The first occurrence is happening on the 12th position, and this is December. This is clean because they don't actually have any ones inside. That's actually how this entire thing was solved. Okay, why I actually want to show this is that I want you to actually think as well when facing coding. Try to always think out of the box as well when you're actually doing this kind of thing. All right, I'm sorry, I have one last thing to show you. So then what is actually the work of a data scientist in actual? Okay, so this is actually my entire stream of work itself. The whole thing is actually all called DSS segmenter itself. So what is actually happening here is these are actually the cleaning part of the work. So this is actually all the file that you see here. That is, this is actually the customer info and all those things. And then what is actually happening is that once this entire thing combined into here, that's actually the end result that you see. Okay, let me just try to swipe across. And that's actually the entire end result. So if I run this, um, I can tell you that what is happening here is that it's running into two machine learning models, and then it has actually around like 8 files. One file is around like 100K cases. So everything is combined, and then with additional file to actually create the demographic, which is around like think of it like maybe say 5 more files, which is around 13 files or 14 files. So how long is going to how long is going to take? No, I know I'm overrun by a bit. So don't worry, it's not going to actually take long. I'm just going to actually share with you. So how long can actually machine learning model actually work out in the background? And all these actually links to cloud from the actual database. So the database runs into data cleaning, into file joins, into calculation, into two machine learning models, calculation, and then out into the actual data itself. And then that's actually what you see here, which is around, it seems forever, but then it will show you the actual timing. Okay, ignore some of these warnings, whatever. It's just because that you buy something, but you're actually not in the loyalty file. You are not present there, so it's just trying to show your warning. That's all. It's fine. Okay. The conversion is because the date is actually not there. It's a noun, so it's just trying to actually say that there's a warning. It's fine as well. Okay. So the entire thing is running. So you can see that it's running until here already, 25%. Okay. Records is joined to 12 groups, 10 groups, and then that's it. 1 minute and 1.51 minute. Yeah, that's actually the total running time. And then this is actually the entire file. So I'm not going to show this one. And then you can see here that this is actually the last purchase price, most purchase genre, transaction, total point orders. The most important point is this one, the strategy. So we know this is a fresh corner, low value. We'll try to pull this fresh corner back. This is win back high value. We'll try to actually win back these high value people. This is actually princess. We try to maintain a premium customer. This is goner. We might want to actually see whether they are still with us and things like that. Okay, so this is actually how machine learning model work, and then this is actually how fast that I can actually work out as using DSS customer observer. Okay, so that's that. All right. Okay, I'm done. Yes, I'm really done.
Yeah, no, thank you. It's so nice seeing you that you are so passionate about what you do. So no worries at all. You're on time.
Okay.
Yes. Before we go on to the questions, just wanted to let you know that we have our session, Let Us Talk It webinar again tomorrow at 12. The topic is how to find your passion, the age-old question of almost every youngster, solved within 20 minutes. So
Okay.
it sounds cheesy, but we'll figure it out how to do it. And so I think the guest speaker has something unique to tell us. And if you want to know more, please do join us. And then the topic, the Let Us Talk It Youth webinar topic for this week, which will happen live on Saturday from 4 to 5 p.m. EST, is on civic responsibilities or civic engagement that the youth can do related to elections, related to politics. The youth are brainstorming. They are working hard to bring in a unique topic for every other youth who will build up the society, the community as a whole. So that topic for you is on Saturday. And other things that we do, among that, yoga classes from on Wednesdays from 9 to 10 p.m. EST, and on Sundays 9:30 to 10:30 a.m. EST. And for all information, you can email us at webinar@letustalkit.com.
Mm-hmm.
Okay, and any question from anyone?
Yeah, thank you so much for such a great session with a lot of in-depth insights. Thank you, Jared. We'll definitely touch base with you offline.
All right. So no question, and so that's it.
Yeah, then thank you everyone for joining
Yeah.
in, and thank you so much, Jared, for your time, your enthusiasm, and it definitely made a difference. Thank you so much.
Yeah, feel free to connect with me on LinkedIn. I'm very easily Googleable. Just type Jared Teo. For some reason, you can Google my LinkedIn out. So,
Sure,
if you
will.
have any questions, feel free to actually ask me there as well. All right?
Yeah. Absolutely. Thank you so much. Bye-bye.
Thank you.
Thank you so much. Yeah. Bye-bye.
Bye.